Welcome back to another episode of Dominic Does DIY. As always, if you haven't subscribed, go ahead and click the subscribe button and click the bell icon. If you find it interesting, if you can share to help out, that'd be great. So in today's episode, we'll be going over part 2 of the moisture sensor device. This one I think might be a little bit faster, a little shorter, because we went over a bunch of the back-end details in the last video. So this one we will be actually focusing on the display side and how to initiate that. So we can come to understand how we can actually use this TFT display to use the data that we're advertising and display the information. So let's go ahead and get started. I'm trying to remember to put links in the description to stuff that's valuable. So in the last one, I tried to give the links to the project files and links to where the items of the stuff that are in the video are. And so this one, I'll try to do the same thing. I'll make another folder and I'll provide a link to the project files here in case you just want to download them. That way if you can't follow along or you're like me and you have to look at the keyboard to type and you just take a while, you can just download these files. They're really basic core files, so there's not a whole lot to them. Now, the first thing we need to understand about our screen is literally what do we want on this screen. We need to know how big the screen is and what information we want to display, because that will determine how big and where our icons are located. So on this one, it's pretty simple. I'm just going to try to keep it simple so we can understand the TFT display. And all I'm really doing is taking a moisture reading, and I want to display that information onto the screen. So that's all we're really going to do. We're going to do a text that says moisture, and then we're going to output some digits on the screen to show the number. And then after we do this, we'll understand how to do a TFT display, and you'll be able to go in there and add whatever you really want to the screen after that. You just got to keep in mind how many pixels and are on your screen, because you only got so much space to work with here. So for this one, I'm actually going to use, in one of my earlier videos, I went through on how to set up our own drivers and stuff like that. To talk to it, but on this one, I'm just going to go easy mode, and I am going to go ahead and just use the TFT eSpy library that's available on Arduino, and then that way it comes with everything, and I can just burn through this a little bit faster. The only thing I am going to do that's a little bit different so we can understand how to actually make this our own is the digits. Instead of using one of their built-in fonts, I'm going to go ahead and treat the digits as an image, and then so I'm going to make that image from scratch and then put it into some memory and go ahead and show how we can take an image and output it to the display, and then that way you can make anything that you want really and put it on the screen and change it as it needs. So it's not just going to be text, it's going to actually be pushing images to the screen. So first thing we got to do is we actually got to create the numbers that we want to use. So I'm not going to get into the code yet, but first we're actually going to make our images that we want to push to the screen. Now, I'm a big fan of the look and feel of just a 7-segment display and those number systems. So I'm just going to make a bunch of individual images that look like that 7-segment display for each of the numbers that I can call out later. So what I used is this LCD image converter, and I just found it online. It's super simple, but allows us to literally convert to the ST7789 format. So we can just download any graphic really, right? And we can take that graphic, we can throw it into this image converter, and it'll output whatever we need in order to display it onto the ST7789 and the TFT display, because there's a certain format that it needs to fit, and this thing will do this for us. But the other thing that's nice about it is you can go into this thing and you can just say file new image. I'll go through this just in case you've never seen it before, and give you an idea of how easy it is, or if you're not a graphic artist like me, it's a lot more complicated to actually make an icon, but this is pretty simple to do. And so first we just got to give it a name. I'm just going to call it image to show it. So we can see here it just comes up good old squares, and so literally you got a pixel right here. So this is a 10 by 10 box, and this is what you'll see on the screen. And so our Display screen, I think it's like 240 by 135 or something like that. But the digit size that I want is going to be 16 by 31. And so in order to get this from a 10 by 10 into a 16 by 31, we got to go up to image here and we got to go ahead and click resize. So when this thing comes up with the resize, you can see our original size right here. And then we've got the new size listed right here. And so the way that this works is with this crop and expand, you just really care about one direction, right? So I'm going to go ahead and go down. I want to turn this into a 16 wide. So I want to go to the right, 6 more pixels. And I want to go 31 pixels down. So we'll just go ahead and put down 31 pixels, but 21, because to get 16 by 31, we got to add 6 to the right, and we got to go down 21 from our original 10 by 10. And then we can just hit OK, and now we got our 16 by 31 drawing area. And so this one takes a little getting used to. So after we've chosen our colors, we got our yellow or green here and the black. And then we go over our draw pixels. And if you hit the right button, well, the left button, I'm sorry, it gives you the foreground color. So that'll be yellow. And if you hit the right mouse button, it'll give you the background color. So if you hit the paint bucket, you can just right click it and we can go ahead and clear out this whole screen. So now we got our black background, because I'm going to do a black background on the TFT display. And now I want to go ahead and just draw in my picture. So now I can just use my left click and start drawing. So you can see here I've already got them all set up. And so this is number 1. Then go in and you see maybe number 4. And you kind of see how all I did was try to keep all these things the same and do the 7-segment display best I could using the space. See what 7, right? We've all seen a 7-segment display before. So I went through and I just did all of this so we can get all our 7-segment displays, digits, all the way around. And when you do this, after you get the segment display, right? So after you draw out your thing, well then how do we get this image into a format that we can actually use in the program? Well, that's where you got to go into File, and you just hit this Convert button right here. And then what it's going to do is it's going to convert it into C code. And so you can just save this 7-segment number 0. You can see I got number 6 saved right there, but you just save it. And then after that, now we got our C code. So we're good to go. We got our images, we got all our C codes. So we don't need the LCD image converter anymore. We can get rid of that. Now we can actually start doing the programming. So inside our program, like always, you got to go in there and just make sure that your platform INI, you can take a look at this with project files that I'll link below. But again, you can see I have that my BLE.h file. It's literally a copy and paste from the other one because I want all these things to be the same, right? These are all those parts of our header file that we went over in the last video. Our product ID and our fancy union that is the union with the structures in it. So we got that. So how is it that we can bring those digits that we just got done doing in the LCD converter? How do we bring those up into a usable thing where we can put into here? Well, first we got to actually open up those C files that we saved. So in that C file that we saved, this is the number 0, right? It's actually kind of nice. It gives you a rough image of what it would look like. But really, all it is a static, just a giant array, right? It's a static constant uint16 data array. And these are the digits that tell the color, which is what the ST7789 chip uses. And so it's just a giant data array. So all we got to do is then copy that. And then I've got my images.h file here. And that's literally all I did. So you look in here, I've got my 7-segment display number 0. I got my number 1, my number 2, my number 3, 4. So you get it, right? I go down. All I did was open up all of those numbers. I opened them up, copy and pasted them in here, and now I've got my static constants. So I've got all my images set up right here, and they're ready to go. So now I can actually use them when I need them. So now that I've got my BLE.h file, I've got my images ready to go. Now we can go ahead and start working on like the program, right? Like getting it to do something. So some of the stuff that I've just declared here is, I don't know why. I haven't looked into too much details on this. If you guys know, you can put it down below. But on this TFT display, the corner is not 0, 0. So after just trial and error, I found that this particular highlight go display that I'm using, its 0, 0 is actually 50, 55, right? For whatever reason, I haven't figured out why that offset's there, but it is what it is. I just made this constant right here for my height and my width, which will be used in one of the function calls. That's pretty much it for the display. This board does have some buttons on it, so that's all this stuff is for, but I'm not using them, so I'm not going into the details. So to use the TFT eSpy display though, what we need to do is we got to create a global variable. So I made a sprite here, but you can ignore it because I don't use it here. We do need the BLE scan, and we do not need the advertised device because we're not going to connect. So that's not really necessary. We're going to need 2 booleans. One is connected, and the second one is matched found. And you'll see why later. But this basically allows us to continue scanning. And this one allows us to actually do work if we find an advertisement that matches what we want. So here in my setup, I'll just walk through a little bit of what it's doing. We got to initialize the TFT display. I'm filling the background, so I'm making the whole background black. I'm setting the rotation based on what I want up and what I want down, left and right. All of this is just to lead in to me being able to write the word moisture, right? So I'm just setting the cursor to this location. I'm setting the text color to white and background of black because the way the TFT display works, and actually just it's not really a TFT display, it's the ST7789 chip. The way that it works is everything that you tell it to do in a square. So you got to give it starting position and its end position, and then it just blocks out, right? So whatever you want your background to be, you got to list your background and you got to list your foreground for the text color. So background's black. So if I want to look like it's just the white letters, then just make the background black of the text and we're fine. And then I set the text size. Then all I want to do is I want to print out the word moisture because that's all I'm really showing. Now I go ahead and I move that cursor again to position 55, even though I don't really need to move the position to it because everything else is going to be pushing images, right? All those images that we got. So at the X and the Y location, give my delta, this is the delta X, delta Y, and the number that I want. So I'm putting in 5 digits because remember when I did the code, it's a 12-bit ADC, and I took 16 samples and bit shifted it right. So I've got a 14-bit number now, which I need 5 digits at the end of the day for if it maxes out. So right now I'm just initializing them all as 0, and then I got to initialize the BLE device. And this right here is, if you look at any example, BLE for Arduino, and for this ESP32 chip, this is basically your boilerplate display, right? I initialize the device, I get a scan object, I declare where my callbacks are. So if I get a match, this is where I want to go. And then some intervals, windows, active scans, and start. Now, the way that this start scan works is kind of unique, I would say, to this. Normally, when you turn a Bluetooth thing on and you say, hey, let's scan, it is just that, it scans like continually. and every time you get a hit, you will call that in, right? So if you just turn this thing scan under normal circumstances and you turn scan on, you would keep going into that callback that you wrote every single time that this thing would be advertising, right? And since advertisements happen every 250 milliseconds, then you would just be constantly, every time the thing would scan, it would see it, and you would constantly go in there. But this scan system works a little bit differently. Instead, you put in a scan time that you want to run it, and I've got this thing set to 1 second. So it basically scans for 1 second and then shuts the scan off, right? So if you want to do multiple scans, you have to keep calling this start scan button. You can't just say start the scan and forget about it and you're just constantly scanning. It doesn't work like that. It scans for literally the time that you give it to scan, and then it stops the scan. Then in the setup, we just set these things to false because I'm starting out, I'm not connected to anything, and I do not have a match. So we set those things to false to begin with. So now I will mention, when you do scan, it will call that callback if it finds anything in the advertisement. So what are we doing in our callback? Well, the first thing we're doing is every time that you get a result, meaning you receive a scan. So when you scan for that 1 second, there's a bunch of Bluetooth stuff that's going on. And you are going to, for 1 second, everything that's happening out there, you're going to pick up. You're going to see it, you're going to read it, and you're going to try to do something to it. And so everything that comes in here, first thing we're going to do is we're going to try to look for, does it have manufacturing data? Right? If it has manufacturing data, that's at least a sign that this is a Bluetooth advertisement that we want to look closer at. So once we know that, hey, this thing does have manufacturing data, let's go ahead and get the length of that data. And also what we're going to do is we're going to go ahead and save that data, right? Whatever that manufacturing data is, we're going to go ahead and save it. And to do that is, remember, this comes in as a string, as a standard string. So in order to get that standard string into something that we can use, because I'm working in the C world here, right? And so I got to convert it to a standard C string. So first thing we want to check is our length. There could be multiple things out there with manufacturing data in them, but of course, I only care about one that has a specific length, and that is my advertising length. So otherwise, if I go try to decipher this, it might get blown up, and it still might get blown up. I'm trying to just limit the teardown a little bit to make sure that I can get the data that I want. So if it doesn't have the number of bytes in it that I'm looking for, then just reject it and return. It's not the advertising data I want. If it is the right length, then I go ahead and I start putting it all into my packet, right? My union structure class thingy that I had, I just start filling that thing up. And now that it's filled up, I just go ahead and start checking for some stuff, right? Which is, does it have the right company byte? I'm just using this as my first round of check. And am I not connected? So long as my company byte matches and I'm not connected, and remember, I'm choosing this because I'm filling it with double zeros. And remember, if it's manufacturing data, then more than likely this is coming from a registered manufacturer for Bluetooth, which means they will have a real company byte there, right? Like there will be something there to signify what company or what manufacturer this thing is. And so if it's 00, it's more than likely mine, because if it was a real manufacturer, they'd have a real number there. And so once I see that it has my company data, then I go ahead and look to see if it has my product type, right? So long as it has the product type that I'm looking for, then I go ahead and say, I found a match. And of course, there's some other stuff, like this is not very, I want to say not very good. Like I could put some more stuff in there to try to troubleshoot and make sure that it's more ensured that it's my advertising data and not someone else's. But for this thing, for what's around, this is adequate enough for what I'm doing. This is just for my house. I'm not trying to sell a product, right? So Now that I found this thing true, then what do I do with that match? I got my bit set here. So we go into the loop. And so what does our main loop do? Well, if I'm not connected, I just scan again. Because remember, this scan, it literally scans for that time. So as long as I'm not connected, every time I pop up here, if I'm not connected, do a 1 second scan, right? And then this way I can constantly scan and looking for the advertisement. Now, if I do find my advertisement, so if I've got a match, then what do I want to do? Well, all I want to do is I want to strip out my manufacturing data, save it as my moisture, and then I want to go ahead and start pushing the image out. So I just do some standard issue digit manipulation. And so this allows me to put in the numbers for each of the locations of my digits. And then I just clear my results and wait a second. That's it. So now every time that we see the scan, every 1 second, we'll do a scan. We'll see the advertisement going out. And then when we see that advertisement, we'll update the display.
So there's the display. It's giving me the ticks of the moisture level in my plant. And so with the 14-bit readout, I found that anywhere between 9 and 10.5 is a good level. So I usually just let this thing sit and tick off. If I get above 10.5, then I go water it until it drops to about 9, and then I'll just let it hover there between 9 and 10.5, and it seems to be working pretty good. And those, so yeah.
Thanks for watching today's episode, and I will see you next time on Dominic Does DIY.